Hello everyone. Today I'm going to give you some brief introduction about MATLAB and the codes of MATLAB. So as you already know that MATLAB is a software for simulation and computing. So this MATLAB stands for Matrix Laboratory. It started in 1984. So this MathWorks, the company having MATLAB software, they are giving you the free license up to 30th of June, as you can see over here. So let's utilize this free license and just learn something new. So for getting this license, you have to type in this URL that I will be sharing with you later on. Then afterwards, you'll get this page. Okay. So what you have to do is you have to create your ID over here. Okay, so I'm clicking over here. So they will ask you your email address, your location, change it to India, then your first name and last name, and then they'll give you an email verification. Then you have to check it, and then you are able to log in into this account, and you may use online MATLAB. Okay, if those who are not having MATLAB software and those who are not having MATLAB licensed software, they can use this facility of online MATLAB. Let me show how I can use this online MATLAB. Okay, so I've already made my account. I'm checking into this. Okay, then so you get a tab over here, access MATLAB online, or you can download the MATLAB on your computer. So I'm going to access the MATLAB online. Okay, so it is taking some time. It is loading. Okay, so here we are. So this is the interface of MATLAB on this URL. Okay, so this you can use easily. This is the command window, and this is your toolbars, and this is workspace. Okay, so you can easily use MATLAB online. So I'm going to teach you some basic commands of MATLAB. So I'll be using my own version of. I'm using my uh, free version of MATLAB. Okay, I'm not using this online MATLAB for teaching over here. Okay, so let's start with our tutorial of MATLAB. So first I will show you some basic calculations that can be done by MATLAB, as it can be used as a simple calculator, it can be used as scientific calculator also. So for simple calculator, okay, so what if you want to use MATLAB as simple calculator? Okay, so simple as didn't type, I'm typing it again. Okay, so first of all, you have seen that I've used this percentage or modulus command. This is used to write comments. Okay, so it is just to write comment to review the code. If some coder is writing some 100 or 200 lines code, then coming back after a week or a month, if he checks, so he may forget that what the code is for. So you must always write this comment aside this any code, so just to know that what this code implies. Okay, so this percentage or modulus command is just for writing comments. Okay, so I'll start with scalar. So what do we have? Let's assign some variable a and give it the value 2. Okay, so a becomes 2. So over here you can see that in workspace, okay, so the variable a has been added, which is having value 2, and it is having size 1 into 1. Then we'll take b equals to 3. Okay, then we'll do basic calculation, that is a plus b, then it will give you 5, then a minus b. Okay, a minus b, it gives you minus 1. Then what about a cross b? A multiplied by b, 26. Then a divided by b, it gives you 0.667. Okay, so what about exponential? So a caret b, it gives you 2 to the power 3 is equals to 8. So over here, whenever we are giving we are doing some mathematical manipulation. So this answer is becoming one variable. So over here you can see that answer is another variable, ans. This is another variable which is having value 8. It is having the latest value of manipulation a caret b. Okay, so you can assign this answer with another variable also, like c equals to a plus b. So now this c will be 5. So instead of ans, this a plus b has been assigned to c. So over here you can see that the variable is given, variable c is over here, which is having value 5. Again the size is 1 cross 1. Size implies it is of row into column, so it is just a single scalar unit, so it is 1 cross 1. Okay, so so now you see another, what if you want to take the square root. So for square root we have a command sqrt. Okay, sqrt supported with this bracket, so we are going to take square root of 2, then we'll get the value 1.4142. so what if you want this decimal point to be more? Okay, over here it is given decimal point only up to 4 digits. So what if you want more decimal points? So for that you need to change the format. Okay, so just look for the format. So for looking of any command, you can just go to the help command, type help, then type format. Okay, so the MATLAB will help you in getting the knowledge or information about its functions and various commands. So format, what does format do? It set the output format. Okay, so there are various types of format that you can use. So you have format short, it gives you scaled fixed point up to 5 digits, then format long up to 15 digits for double, and 7 digits for single, then short e and long e. Okay, so there are various types of different format that you can look up to. Okay. So for our problem we are just going to use format long in this case, and then again let's see the square root of 2. Okay, so now instead of getting 4 digits from decimal point, you are getting more than 4. How much it is? Let's count 3, then 3, 6, and 9, then 12, and then 15 digits. Okay, as I was telling earlier, it is mentioned over here that you will get a scaled fixed point with 15 digits. Okay, and now what is left? Then there is a very good command. This is, instead of a divided by b, let's see this backslash, a is backslash b. Okay, so what is a backslash b? Let's see the answer. It is giving you 1.5. Remember the b is value 3 and a is 2. So what is this a backslash b gives you? It gives b by a. Okay, it gives you b by a. So if you are using a slash b, it gives you a by b, and if you use a backslash b, it gives you b by a. Okay, remember this point. And then we move on to, okay, we have seen square root, format, help. Okay, then what if you want to know what are the prime numbers? Okay, so I'll delete this window. This I will just clear. Okay, so clear the command from command window. Use the command clc. Okay, if you want to clear the variables over here from, if you want to clear the workspace, okay, then use the command clear all. Then you can see the workspace has been cleared. Okay, if you want to clear the window, command window, then use the command clc. It will clear the command window also. So use both of them together always. Okay. So now let's see the next command, which is prime. So how do we find the prime number up to some digit, like prime number up to 10 or prime number up to 5? So for that we have a command primes. Okay, so let's look this command with the help window, help, then typing primes. Okay, remember this is primes, primes, and not prime. So the primes generate the list of prime numbers. Okay, so primes bracket n is a row vector of prime numbers less than or equal to n. So if I type in primes, okay, bracket I type in 10, so I'll get prime number up to 10. Okay, that is 2 3 5 7. So if I want primes up to 20, so I'll get like 2 3 5 7 11 13 17 and 19. So this you can keep on changing this value n to whatever you want. Okay, so there is another command known as isPrime. Let's see what this isPrime do. So okay, isPrime is true for prime number. So isPrime x, x is some number you want to check whether it is prime or not. So isPrime x is 1 for the elements of x that are prime and 0 if it is non-prime or if it is composite. Okay, so let's check whether the number 7 is prime or not. So I'm checking the number 7 whether it is prime or not with the command isPrime. So since it is prime number, as you can see over here, primes 20 gives the 7 also as a prime number. So for 7 it is returning the value 1. So what if I check whether the 8 is prime number or not? So I am typing isPrime 8. So it is returning the value 0, which means the number 8 is not a prime number. So as an assignment, you can write a program to count the prime numbers between 100 and 150. Okay, so you can write a program to count the prime numbers between 100 and 150. You can use the command prime and isPrime. Okay, so I hope you can generate this program. If any difficulty, you can also contact me over email. Okay, so I'm clearing this window, clear all, CLC. Okay, so what is left now? So okay, so now let's see various mathematical constants, okay, which is inbuilt in MATLAB. So first is pi is that is 22 by 7 or 3.14. So you're getting the value 3.141592. Okay, so if this is very long, then you can change the format using command format short. Okay, then type pi again and you get the digit up to 4 decimal 3.1416. Okay, so another is exponential. So exponential 1, okay, it gives you 2.7183. Then we have complex number I. Okay, so what is this complex number I? This is the square root of minus 1. Okay, it is the square root of minus 1. So it gives you 0 plus 1i. Okay, so like if you want to write some complex number, then you can write 3 plus 4i. Okay, remember, do not write as 3 plus i4. Okay, and this is the wrong syntax. It will give you some error. So always write like 3 plus 4i. So I will clear again the window. So now after the mathematical constant, let's see the physical constants. Okay, so for physical constant, we have a command physconst. So we are getting physconstant Boltzmann, so we are getting 1.38 into 10 power minus 23. So let's look this command physconst with the help command. Okay, so physconst, it gives you physical constants of natural phenomena. Okay, so various physical constant in MATLAB is light speed, Boltzmann, earth radius. Okay, so we can check this light speed also. Okay, I'm copying it over here. So it is giving you, okay, we know that it is 3 into 10 to the power 8 meters, so it is approximately 3 into 10 to the power 8 meters. Exactly it is 299792458. Okay, so this was phase constant, and over here you see that we are getting Boltzmann constant as 1.38 e to the power minus 23. Okay, this represents 10 to the power minus 23. Let me show over here also. If I write like 1e1, okay, so it gives me 10. So this 1 represents the coefficient. If it is like a into 10 to the power x. So over here this a is 1. Okay, and so if I write like 1e2, so I'll get 100. So this is 10 to the power 2. So before that the coefficient is 1. If I write 2e2, I'll get 200. So coefficient becomes 2. So 2 into 10 to the power 2, it gives you 200. Okay, so do not confuse it with exp. Okay, this exp is the exponential 2.7183, and this e is your 10 to the power x. So now next is trigonometric functions. So for trigonometry we have sine, cos and tan. So let's first introduce the theta. So theta we are taking over here as 45. Okay, so let's introduce another phi. We are introducing as pi by 4 in terms of radians. Okay, so over here pi by 4 is given as 5. So let's take a equals to tan then theta. Okay, remember you are using this theta as degrees and you are using phi in terms of radians over here. So if you want tan of this theta, so you do not write tan over here, we write tan of d. Okay, so tan of d, that is tan 45 gives you 1. So just look up this command help tan. Okay, so it gives you tangent of argument in radius. Okay, so since we are having theta in terms of degree, so we are not using this tan. What we are going to use is tan d. Okay, over here. So what is this tan d? It gives you tangent of argument in degrees. Okay, so if you want to use phi, so we are going to use phi. So for phi we are going to use we are going to use tan instead of tan d, as this phi is pi by 4. So over here again the answer is 1. Okay, so what about tan inverse? So for we have introduced a and b and phi and theta. So let's take another variable as c. So let me clear first. Okay, then c equals to a tan. Okay, and a tan, if I want in terms of radians. Okay, so this is giving me in terms of radians a tan. So this is pi by 4. If I just compare this as pi by 4 is okay. So this c and this answer is same. Okay, if I want my answer in degrees, so I will write a tan d. So I will get the answer as 45. Okay, then okay, you can also get phi. You can also write sine also in terms of sine phi. Okay, like this. So you get sine phi or sine pi by 4. Okay, so sine pi by 4 is what? 1 by root 2. So you can compare also sqrt. So we are getting the same. So now let's see another command that is cos hyperbolic or sine hyperbolic. So if you want cos hyperbolic, for that is command is cos h. Then you can write 5. So we get the value as 1.32. Okay, so this e plus 0 is just 1.32 into the power 0. Okay, so this represents 10 to the power 0. Okay, So let me clear again. So next we have another mathematical operator, that is logarithms. We'll see how we'll find logarithm in MATLAB. Okay, so for log we have a command log. So we'll see it with the help command. So log gives you natural logarithm. Okay, so what about log base 10? So this is ln x, so this is base e. So what about log base 10? So we have log 10 over here, so you can search it over here. So this gives you common base 10 logarithm. Okay, so okay, I will clear the window. Now if you want to take ln of 3 or natural log of 3, so it gives you value as 1.0986. So what about log base 10 of 3? So that returns the value as 0.4771. So this was log. How to take anti-log? In case of a natural log, we will take command exponential. So exponential of 1.0986. I am taking the exponential of this one. Okay, so this should return the value as 3. Okay, so these both are same. Okay, so in case of a base 10, we will take just 10 caret and whatever the constant that we need to find the anti-log for. So in this case, okay, it is giving near about 3 only. So now the next is complex numbers. Okay, how to find the magnitude or the modulus of complex numbers. So we have z equals to 3 plus 4i. Okay, so in case of this in this complex number, for modulus, okay, I will write here, so modulus of z, so we'll use the command abs. Okay, so we are taking another variable z1, so it is equals to abs, then we'll take the variable z in here. So this gives you 5. Okay, so this is 5 is equals to under root of 3 square plus 4 square. So this abs gives you the modulus of any complex number. Okay, so next very important is roots of polynomial. Okay, so roots of a polynomial, how we will find with the help of MATLAB. So let's first describe a polynomial. Okay, so I am taking this one. Okay, so we have described a polynomial with an array 144. So this gives the coefficient of the polynomial, which is this polynomial can be seen over here. This is x square plus 4x plus 4. Okay, this 144 are the coefficient of this polynomial. Okay, so we have described the polynomial. Now how to take the roots? So for this I am taking a variable r equals to, command is roots. Okay, remember this is roots and not root. So roots, and then we'll give over here is the polynomial p. Then answer is -2 and -2. Since this is a quadratic equation, so it will have 2 roots. So both roots are over here is -2 and -2. Okay, so you can have more complex roots over here. You can just give some array of some array of like 1 2 3 and then 0 0 0 and then 5, like this you can give. Okay, so this is having like this is x square, x cube, x4, x5, x to the power 6. So this is x to the power 6 polynomial. So these are the coefficient, and you can just take the roots, okay, of this polynomial p. So it is giving you 6. This is to the power 6, so this is giving you 6 roots, so out of which all are some complex number. Okay, so like this you can get the roots. Okay, so just I will clear. The next is very important, that is plotting. Okay, so we'll go for now. Very important tool or command in this MATLAB is the plotting, how to plot any function. Okay, so we'll plot a sine function. Okay, so we'll plot a sine function over here. So I will take one angle theta. Okay, so I'm describing this theta from 0 to 2 pi in steps of 0.01. okay, so over here this particular command is very smart command. It generates an array from 0 to 2 pi in steps of 0.01. so the first, you can see this A, B and C. okay, one column. So this is like this: A colon, B colon, C. okay, so what happens, this command will generate an array from A to B in steps of C. okay, so over here it will generate an array from 0 to 2 pi in steps of 0.01. okay, so I will put a semicolon over here. I will explain this semicolon okay later on. So now this theta has been added over here to the workspace. okay, so this, if I double click it, I will see that okay, so this is your theta. So it is an array of incremental steps of 0.01. so this is 0, 0.01, 0.02, 0.03, and it will go till 2 pi, which is 3.14. so it is taking 6.28. okay, now this semicolon command, okay, over here you see that when we use this semicolon, what happens, there won't be any result in this command window. okay, so this semicolon suppresses the answer in the command window. Rather, it just stores this array over here, the value of array in the workspace. Since it is having like 629 digits, so 629 elements are there in this array, so it will totally crowd this command window. So I'm just going to use this semicolon just to suppress the answer on the command window. okay, nothing else. Now I will just copy it over here. okay, so okay, so there is a function f which is a sine of theta. So now remember, this sine of theta, it also acts as an array function, which means it gives sine of each element in an array. okay, so like it is having 629 elements, so this sine theta will give sine of each element and it will store as an array only. So again, since it will have 629 elements, so I will use a semicolon so that it will not crowd the command window. okay, I will press enter. Over here you can see that again this is having 629 elements. So if I check this again, we are getting some value of sine. okay, now we'll plot. So plot, for 2D plot we have a command plot. okay, so we'll plot. So this command will use x comma y. So the first one will be x-axis and the second will be the y-axis. So we are plotting theta versus sine theta. okay, so this plot command is it will give you a 2D plot. okay, so now over here you can see we got a nice sine wave function over here. So this is your sine function, this over here is the theta. So just we need to label this x-axis and y-axis, and there is no title also. So for all this thing, to make the plot bit pretty, we have some commands like this. So this x label, it gives you x-axis, it labels x-axis. okay, so in x-axis we are having theta, so we are just using x label, then bracket, then colon, and inside we are writing theta. Then for labeling of y-axis we have y label. okay, so y label, then sine theta, so it labels y-axis. okay, then over here we want title also on the top of the plot. So title is the plot of sine function. Then if you want the grid to be on, okay, so that is grid lines, then we use the command grid on, and if you press enter, then we go to our figure. okay, then you can see a nice figure over here which is having grid lines. okay, then y-axis is having sine theta and the x-axis is having theta, and the plot is also having a title on the top, which is plot of sine function. Now one thing, if you want to do, you can do one more thing. In this of theta, instead of writing this theta in like in alphanumeric way, in alphabets, if you want to write in a Roman letter, if you want Roman theta over here and Roman letter theta over here, then you have to do a simple change. Okay, then we'll use a latex command. Okay, for latex, those who are using latex, they may know that if we just add backslash over here, so this gives the latex command for theta. Okay, so and for y label, okay, again I will add backslash over here. So again press enter. Now if I see my plot, so now instead of alphabet theta, we have a Roman letter theta. Over here also Roman letter theta. So you can change this. So we have so many Roman letters. You can have theta, you can have psi, you can have phi, you can have zeta. All those things you can have. Just add this backslash and write the correct spelling of those Roman letters. Okay. So now we'll do a special. We'll do a special plotting. Okay. So we'll plot. Okay. Let me clear everything. Clear and CLC together. Okay, so what we are doing, we are going to plot a circle of unit radius. Okay, so now over here we are creating a vector theta with the help of this linspace command. Okay, so you can create an array with the help of two types of command. The previous one was using colons, and here you can create array with using linspace. Okay, linear spacing. So it gives, okay, this ABC. Okay, you can see this A, this is B, this is C. So this creates an array between 0 to 2 pi and having like 100 units. Okay, over here. Okay, so 0 to 2 pi will have 100 divisions. Okay, so now x is r cos theta and y will be r sin theta. Since we are having a circle of unit radius, then this r will become 1. So over here x will be cos theta and y will be sin theta. Again they will generate x and y coordinates in an array. So we'll plot the circle. So we'll use a plot command, plot x comma y. Okay, so we'll get a circle like this. Now it may not look like a circle properly because the axes are not equally divided. Okay, so it is looking like some egg shape or some ellipsoid shape. So for equal axis we have a command axis equal. Okay, now if I go to my figure, okay, now this is looking like a proper circle. Okay, again you can add x label, you can add the y label, x label, and the title. So if I simply add the title will be plot of a circle, Okay, so over here we get the title of the plot. Okay, okay, so now as an assignment you can plot this one. Okay, so you can plot a circle of a user defined radius. So over here we have plotted a circle with unit radius. So I want you guys to plot a circle of user defined radius. So you require a command. So I will just give you a hint of this command, so you can go help input. Okay, so you need to input the radius as a user defined variable. Okay, so you can read about this input command. So it prompts for the user input. Okay, you can see more about this input command in this document, doc input, if you click. Okay, so it is taking some time. Okay, so over here we have the input command. Okay, so you can get some examples of how to use the input command. So this is all for today's session. So thank you for listening. So tomorrow or in the next class we'll see about arrays and some matrix manipulation and some special commands like Taylor series expansion and factorial in the MATLAB. Thank you everyone.